force of gravity is this, so I'm going to call that F1. And this is R1. If they're moved so that their separation, this is R2. What is the new force? I'll call that F2, right? So we know that F1 is G_mm over R squared. We know F2 is G, same two masses, right, over, and that's R1 squared. This is R2 squared. And I can divide left by left and right by right, which makes these guys not matter, right? So I end up with F1 over F2 is R2 squared over R1 squared. Okay, so let's see, what are we solving for? We're solving for F2. Okay, so I'm going to rewrite that. I'm going to go F2 over F1 equals R1 squared over R2 squared. I just flipped them both over because this is easier for me to picture, right? Because now I can just do this F1, and now I've got an expression for F2. So F2 is going to equal R1, where's R1? 1.1. R2 is 3.2 squared, right? And then our force is 6 times 10 to the minus 11th. Right? The units of these, by the way, are not important because they're going to cancel out. And notice we're going to get less. We're going to get less force because we're farther apart, and that makes sense. So if you ever set up this thing and set it up, and you're like, get the 3.2 on top. On this case, it just wouldn't make sense because you'd get more force, which of course it's farther apart, so it's less. So just do a little reality check there. Okay, left parenthesis alpha F1. 1.1, and then the denominator is 3.2. Go to the right. Let's square that. Times 6 e minus 11. And I'm getting 7.0898 times 10 to the minus 12th newtons. So 7.09 times 10 to the minus 12th newtons.